We're going to solve trig equations still, but this time we are going to use two methods, factoring and the square root method when necessary. An equation whose variable is expressed in terms of a trig function is still a trig equation. Now, what I want to do in method 1 here is to factor this to solve it. The way we factor it is the double bubble. It's the difference of two perfect squares. 4 sine squared theta is the same as 2 sine A and 2 sine A. And the 1 is 1 and 1. It's a difference of two perfect squares, so plus 1 minus 1. You split it. And then what you would do next is set them both equal to 0 and solve. So setting the first one equal to 0, you would have to subtract 1. Then you would have to divide by 2. And then you would do inverse sine. So you do inverse sine of negative 1/2, you get negative 30. Negative 30 is in quadrant 4. When you get a negative angle, you always want the positive side of it first. The positive side of negative 30 is 330. You're in quadrant 4. Sine is negative in quadrant 4. Sine is also negative in quadrant 2. These blue reference angles are the same at 30. You want the black angle, which is 180 plus 30, which is 210. On the right-hand side, the same idea. We're going to add the 1. We're going to divide by 2. And we're going to take the inverse sine. And you get 30 degrees. To get the second angle, we graph 30, which is in quadrant 1. Sine is positive in quadrant 1. Sine is also positive in quadrant 2. My red reference angles are equal at 30 degrees. I want the blue angle, which is 180 minus 30, which is 150. And that's it. So we get 4 answers there. The other way we could do this particular problem is the square root method. You can only use the square root method if you don't have a middle term. Look at these two problems below. This has a middle term of sine theta. This has a middle term of 3 tan theta. Since these have middle terms, you can't use the square root method. But this one does not, so let's use the square root method. To use the square root method, what you do is you start by adding 1. So you'll have 4 sine squared A equals 1. You divide by 4. So you'll have sine squared A equals 1/4. Take the square root. This is the hard part with the square root method. You have to remember when you take the square root. Okay, the first answer you get is going to be sine of A equals, the square root of 1/4 is 1/2, or sine of A equals negative 1/2, positive or negative answers. I'm not going to go through the whole process again because we did it already on the left-hand side, but when sine of A was 1/2, A was equal to 30 and 150, and sine of A was equal to negative 1/2, A was equal to 330 and 210. So 2 different methods to solve the same thing. We are mainly going to use the factoring method today because we don't have any where we could use the square root method. I'm going to skip the second one. Let's do the first one together. So to factor this, we're going to start with a double bubble. 2 sine squared theta. The only two factors of 2 sine squared theta that I can use are 2 sine theta and sine theta. And the factors of 1 are 1 and 1. I need to add or subtract to a positive sine theta, so this is going to be plus and that's going to be minus. If you didn't believe me, you could test it out, you could FOIL it, and you would see it work. From there you split it. You set them both equal to 0. When I set the first one equal to 0, I'll add the 1, divide by 2. So I get sine theta equals 1/2. Well, I've done all the work above, so I'm not going to show it again. I'm going to try to save some time. Once sine theta equaled 1/2, we got theta was 30 or 150. On the right-hand side here, I'm going to subtract the 1. So sine theta equals -1. And you do inverse sine, which is -90 degrees. We graph -90, which is a quadrantal angle. The positive side of it, because I need a positive number, is 270. Now to see if there's a second angle, what I do is I test the other side. So in my calculator, I type sine 90. And if it gives me -1 as an answer, then it works. If it doesn't, then it doesn't work. When you type it in, it gives you +1 as an answer, so it does not work. So only 270 works for that one. I'm going to have you guys try the tangent one. Moving down. This next one, notice there's no squared on it like there was for the other ones. However, I will still factor because I see a GCF. The GCF between the first two terms is cos theta. If I take a cos theta out of the first term, I'd be left with a 2 sine theta. And if I take a cos theta out of the second term, I'd be left with a 1. Now that you factored it, you split it. Cos theta equals 0. You do inverse cos, and you get 90 degrees. We graph 90 degrees, which is another quadrantal angle. That means you will test the other side, which is 270. In your calculator, you type cos 270. You do say it does equal 0 like it has to. So it works. The directions do say it wants it between 0 and 2 pi. So 90 degrees as a radian value, take 90 divided by 180. You get 1/2. Put a pi in the numerator, pi over 2. And then you take 270 divided by 180. Change it to a fraction, and put a pi in the numerator. You get 3 pi over 2. Sorry, that's a mess. 3 pi over 2. So those are your answers on the right-hand side. On the left-hand side. On the right-hand side, let's subtract the 1. So 2 sine theta equals -1. Divide by 2. Sine theta equals -1/2. We did this above. When sine theta equals -1/2, you get -30. But the ones that really work are 330 and 210. If I want radian values, I'm going to take 330, divide by 180, and change it to a fraction. And that will be, hold on one sec, 11 pi over 6. Then I take 210 and divide by 180 and change it to a fraction, and that's 7 pi over 6. And one thing I did notice at the end here, it says find the nearest hundredth of a radian. So I have it in terms of pi right now. To change it in terms of a decimal, what you do is take 11 times pi and divide by 6, and you get 5.76. And you do the same thing, 7 times pi, divide by 180, or divide by 6, and you get 3.67. For the left-hand side, I'm sorry, I do have them as pi values, but we do need it to the nearest hundredth. I'm just going to write it over here. Pi over 2 to the nearest hundredth is 1.57. 3 pi over 2 to the nearest hundredth is 4.71. I'm going to ask you guys to try the other problem as well. Answers.